Okay, in this tutorial, I'm going to teach you how to actually gather field data when you're out and about. Um, we're obviously going to be doing it virtually. We're going to be visiting 10 locations that have been selected for study in St. Andrews. Now, in the last tutorial, I looked at how to actually put pins on to a map. And you can see I've gone and completed that map now with 10 locations selected that are all on roads at junctions. What we now want to do is visit those locations, and when we go there, we want to gather some observational data. And the technique we're going to be using is known as a bipolar analysis. Now, at this stage, what I'd recommend you do is you might want to go back to the virtual the virtual textbook, Student Textbook 2020, and turn to page 65 and just have a quick review of bipolar analysis. A quick explanation of bipolar analysis is it's the way that we can turn data that is observational data, something that we look at and see, what we might call qualitative data, into something that is usable, quantifiable, that we can turn into maps and do some analysis for, which is called quantitative data. And this technique uses a simple scoring system. Now, there's a range of scoring techniques you can use, but if we look at this example here of an environmental quality index, we can see we have a whole range of categories that we're going to be scoring our location against. So now this could be any location, it doesn't have to be St. Andrews, and we could change these criteria to be anything we want. We've just got to think of what's something that is positive in the environment that we are studying, and then the opposite of it. Now, the scoring system you use doesn't have to be the one we've got here. This is the most famous one, the bipolar system. But it could be more like the one used here, where you're scoring on a score of 0 to 5 or 0 to 10. And there are a range of ways that this can be done. And you're probably more familiar with scoring systems that score things on a scale of 1 to 5 or 1 to 10, always where the lower number is the worst and the higher number is the best. The reason the bipolar system is most suitable is it's best for when you're scoring something when there is a positive and a negative aspect to what it is you're scoring. And the reason it's really good is if you don't think there's something that's positive or negative, you can simply just score it 0. So if you have no view on it, or you don't think it's positive or negative, you give it the 0 score. It allows you to be neutral. Whereas on a scale of 1 to 10, 5 is not necessarily neutral, because 5 suggests a better score than 1. So 5 is more positive than 1. Whereas on a bipolar system, what 0 can represent no view, no score. It's also small enough. It's only got 5 points. You'll notice there are 1, 2, 3, 4, 5. Therefore, you're not having to make a massive and nuanced judgment, as you would do if it was a 10-point scale. And this is the really important part. It's got a negative side and it's got a positive side. Now, why is that important? Because when you think about something like, are there a lot of pedestrians or not many pedestrians in an area? If there aren't many, you want to clearly show that that is a negative. For example, it might be to do with being a shopping area. Whereas if there were lots, you might want to show that that was a positive. And if you're very positive about it, you would go with a +2. If you thought it was still reasonably positive, you'd go +1. Or 0 if you didn't think it was neither positive or negative, what the particular criteria that you're judging. And if you're sort of negative about it, then -1. If you're very negative about it, then -2. And it could be any criteria. So if you look down this list, you'll see, is the area quiet? And if it's quiet, then that's a positive aspect for an environmental quality. If it's very noisy, then that would be a negative, so you'd be giving it a -2. So you'll see the wording on the left and the right-hand side for the positive and negatives are exact opposites of each other. So you're going to be using this +2 to -2 bipolar system in your virtual visit of St. Andrews. So let's go back to St. Andrews and show you how you're going to do this. Before we actually drop into our first site, let's have a little look at our spreadsheet, which in the last tutorial I asked you to open up. Now, you will see I have selected 10 criteria. Now, I've laid them out a little bit differently from this way. And there's a reason for that, which I'm not going to bore you with right now. But I've chosen 10 of these, and I have put them up here. And you'll see I've got, for example, the first one, the volume of parked cars on the roadside, -2 if there's lots of cars, +2 if there's few. The second category is a pleasant, attractive building. So the buildings in the area nice to look at, -2 if they're very unattractive, +2 if you think they're very attractive. And you can just work your way down each of the 10 criteria, and you can see what the -2 criteria is and the +2. And you decide on your score somewhere between -2 to +2. So you might go for -1 or 0 or +1 or +2. It's up to you based on the environment you drop in. Once you've put a score into each of these cells, it will do the totaling for you. Because I've created a little formula which you can see, which is equals sum B2 to K2, which means it's going to sum all of these. So if, for example, you felt this was really bad, you would enter -1. So you thought there were lots of parked cars. If you thought it was pleasant and unattractive buildings, and you actually thought, no, the buildings are quite attractive, I'm going to go 2. You don't need to put +2 if it's a positive. And you think that's a 1, and you're going to go a 0 for the environment and surroundings. You think it's a bit noisy, so you're going to go -1, and so on. And gradually, it will change this number here as you add more in. There is a possibility, because we've got 10 categories, 2 for each one, that you'd have a score of 20. And if you went -2 for every single one, you'd have a score of -20. So we could have a range of anything scoring a brilliant environment. A very high quality environment would get a total of 20. That would be the best you could get. And a very low quality environment would be -2. The only other thing you need to do to start completing this table for your 10 sites is to go and visit those 10 sites. Now, to do that, we're just going to use the little function. So here we are at site 1. I've just dragged it down and zoomed a little bit. And I'm going to pick up this little guy here, and I'm going to drag him across, holding my mouse button down. You'll notice the streets come up in blue, and then I'm going to drop him over my point. And what he's then going to do, once again, is the slow bit. He's in to that actual environment, and it's going to load. And there we go. So I am now in St Andrews at site number 1, just like in a real field trip, and I can see trees. I can't see any parked cars. Can I see any pedestrians here at all as I spin the whole 360? Not a single pedestrian, but I've got some parked cars, got a little bit of traffic. I can see lots of green vegetation and trees. I'm able to make a judgment about the building qualities. Basically, in this environment, I should be able to now, spinning all the way around 360, do 2 things. And the first one is give a score to each of these 10 categories. Second thing I should be able to do is I should count every single person I can see walking with that 360 view from where I dropped myself. And I will then enter that number in there. I'll then repeat the same for site 2, all the way through to site 10. So if you want to get out of this, all you've got to do is hit the little back button there, and it'll drop me out. And then I can drop myself into site number 2, lifting up the eye. So I just go over, click down the mouse, he goes yellow, the streets then go blue, and then I let him go when I'm over my site. And once again, I will zoom in at that location, and I can go exactly the same way, making my own judgments. I count the people I can see, so I can see 1, 2, 3, 4 there. I can see 5, 6 there. I'll keep spinning around. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Don't worry, you're not exact. I'm back to where I started. I've got roughly 22 people at this location. And I would also do my environmental quality for site 2. And work through all 10, and I should have a complete data set with totals given for all 10 sites and totals for 10. Now, just before we finish, I want to talk a little bit about one of the problems with this type of data gathering. You'll have noticed we're making all of these scores based on our own judgments. Now, whilst the pedestrian count is reasonably accurate, in the sense that, no one's moving. It's not like if we were in Braehead Shopping Centre and people were whizzing past and we'd struggle to count them. We are looking at photographs at the end of the day. So that should be fairly accurate data. The problem we have with the environmental quality data is it's very what we call subjective, and what I mean by that is it's based on your own views. And one of the problems with that is it can lead to bias. So you might, for example, have a preference for old buildings over new buildings. Um, and therefore, you might think old buildings look more attractive than new buildings, and you would therefore give it a +2. Or you might be somebody that has the exact opposite view, and you think modern buildings are attractive and old buildings are ugly, and you might give that a flip score. So it is subjective. It is prone to bias, and therefore your totals are going to be the totals you give. If you're wanting to prove on that data gathering technique, you might want 4 or 5 people to do each site individually and then work out an average score for each location, and that would give you a much more authentic piece of data than if it was just yourself. Okay, so that concludes tutorial number 2. In my next one, I'm going to show you how to use that data to create a proportional symbols map.